Let's talk VDML with KJR.
Welcome to Let's Talk VDML. It's practical conversations about trusted AI adoption. This podcast is brought to you by KJR, Australia's leading trusted advisor in software quality engineering and AI innovation. I'm Kelvin Ross, I'm CEO of KJR. What we're trying to do in each episode is we dive into the opportunities and challenges of responsible trusted AI adoption, and then look at the governance and assurance. But we love to engage with industry experts and thought leaders in that conversation. Today we've got Evan here. If you enjoy the conversation, don't forget to like, subscribe, and stay connected. So today, as I mentioned, we've got Evan Shellshear, co-author of Why Data Science Projects Fail, and you've co-authored that, Evan, with Douglas Gray, right? It's I've known Evan for many years, and Evan, you're someone I really admire and respect in the industry, not just because you've got that deep foundation in the data science field, but also the talks and the forums that we've been in at universities around business leadership, skills development amongst the industry, and those are things that I think I really respect those things. But Evan, I want to start with you, and I think let's start around your background. How did you get into this space? You're a real data scientist, right? Not one of these sort of LLM hackers that are out there. So.
Absolutely. Thank you for the kind introduction, Kelvin. The respect is definitely mutual. I think from your side, I've always kind of looked up to you as someone who's successfully turned a lot of sophisticated theoretical work into practical benefit for industry. What you guys do at KJR, I know your PhD and your background there form kind of the basis for a lot of the assurance work that you go do, which is impressive. I see so many people doing PhDs and all sorts of things that just kind of don't really get anywhere. They fail that commercialization, whereas you guys have done it, which is impressive. But on my side, what kind of drove me, I think, to come to where I am today was a passion of mathematics that I discovered, I think, in about grade 2 when I was a little kid. I still remember the teacher handing out a set of little exams. I think they had like 40 multiplication questions or something on it. And for some reason, at that moment in my life, I decided I wanted to be the fastest. I had to do this the best. And so I raced through all the questions, wrote down all the answers, ran up to the front like this happy little kid and handed in the test, excited to see how it went. I think I must have done pretty good, because after that, it was just kind of like maths was for me. And so there began a journey where I got to university and went so far as to have in one of my degrees a double major in maths, and in the other degree a single major in maths. So I had 3 majors, which I think when I graduated, the graduation committee were a little bit shocked that someone could do that much mathematics. But I then kind of moved on to do a PhD in applied mathematics and game theory over in Germany at the University of Bielefeld, and then kind of decided, look, I'd had enough. I think academia for me, although it's interesting to do that pioneering stuff, although it's interesting to be on the forefront, sometimes you ask yourself, what am I on the forefront of? Like, what am I actually doing here? And who cares really? So what if I publish a paper? If no one cites it, if no one reads it, if no one downloads it, then what did it matter actually? And so decided to make the pivot to industry at that point. And ever since then, I've been building AI models for like the last 15 years in everything from robotics to supply chain and logistics, agribusiness, healthcare, retail, currently doing it in HR and recruitment space.
Thanks for tuning into this episode where we're going to talk about practical AI assurance. Make sure you head over to our website, check out our events page. There's heaps of AI events on there, AI assurance, AI governance, AI guardrails, AI everything. Check it out right here. Make sure you like and subscribe so you don't miss any of our epic episodes of AI assurance.
No, I love that trajectory as well. And again, something, I did a computer science degree and a PhD, but a lot of mathematics, like formal method stuff. But I was a bit the same. Like once I got to postdoc, it was going, you know what I really like is working on real problems with industry, because there's a lot of problems that come up in that still require deep thinking and how to solve it. And I think switching over to that was, for me, created a lot of relevance and grounding, as opposed to researching, in the lab sort of thing.
Exactly. And there's no reason why you can't do both nowadays, to be honest with you. One of the things I've done is maintain an adjunct professor position at a number of universities. And that kind of satisfies that intellectual curiosity. It satisfies that drive to want to to investigate, to publish, to research. And so I'll still do a few papers every year in peer-reviewed journals and stuff like that. And that kind of scratches that itch. But exactly like you said, you can see the impact in industry now with the day-to-day work you do. And it's great.
Yeah. It's we're a pretty proud maths family as well. My daughter's doing a PhD in cosmology, but she did a maths physics background. But she's pretty much just doing data science, right? It's
wow,
so I tease her about it a lot. Crunching data on two million galaxies and stuff like that. And but she definitely wants to pursue that research area. But there's the analytical skills, the fallback into data science and things like that. There's heaps of opportunities out there. So there's so many things that theoretical foundation can lead to.
That's fascinating, that final point you made. It's so fascinating because 10 years ago, when people talked to me and asked me where do I get data science from, you know what my answer was? It was physicists. It was go get the physicists, because they'd be using big data. Typically, they're using advanced maths and they're having to program. So not like the pure mathematicians that can just do with pen and paper. They're actually having to calculate things and produce results. So it's
and it's all
awesome
the empirical validation and stuff like that, right? No, but she says, finally getting to do some mathematics, because she's looking at the physics of things and stuff like that, which it ends up being a small part of the work, right? So, but I sort of love that. And even that point, I was chatting to somebody today, when she was doing a degree, some school teacher said, what can you do with mathematics? A school teacher? And you go, oh my God, like just about every industry, there's heaps of opportunities.
It's so true. In fact, it's so bad. One point on this, just also to raise, it was so bad when I finished my degree in terms of the awareness of what you can do with maths. And because the maths department was theoreticians, it was pretty much you only went to do a PhD. So about 5 years ago, I sat down with the Maths Student Society at UQ, and we finally did something that's been missing forever. We mapped out career pathways for mathematicians who are studying mathematics, and we showed them everywhere you can go. And it was this huge list. And what we did for the first time ever, not only did we map that out, we then mapped out what courses you need to study, what internships you have to do, and gave people this unique pathway for them to be able to follow a mathematical career into industry and receive guidance from that, especially in case that your maths department or whatever are more theoretical and don't lean in on the applied side. But that was exactly to address that issue that we finally 5 years ago just nailed it at UQ.
Yeah. Oh, cool. Okay. There's lots we could explore there as well, like curriculum and data science degrees and things like that. But I think we'll have to organise some more episodes, I think. So before we get in, a quick one: AI optimist or pessimist? Where's AI heading, and where do you sit in adoption?
Oh, I'm definitely on the AI optimist side. Definitely on the AI optimist side. I clearly am aware of the challenges and the risks, but I'm also aware of the opportunities, the possibilities. I like to play around with kind of cutting edge tools and seeing what they can do. And obviously, I'm using them for good and using them in a positive way, and seeing the impact it has in a positive and good way is incredible. And it's just like anything I think out there. I think a lot of the AI pessimism for me arises from exaggeration of what the AI can currently do and where it's going. I think that arises from people's imaginations going beyond what it is. I always like the famous or the hilarious comment around that, we should be worrying about AI wiping out the human race right now as much as we should be worrying about overpopulation on Mars. Right. It's it's not that it should not be the number one concern at the moment. There are other concerns that are more important that we should be focusing on from an AI perspective that are real, that are causing issues right now, like data and privacy issues, breaches, all those kind of things. But I'm definitely in the optimist camp.
Yeah. I think I'm in the same boat as you. I'm that optimist. But again, this comes back to the theme of your book is, I continuously focus on failure, right? Like, because again, what are these elements where some of those threat areas or risk areas are, and how do we actually, build a robust, responsible system around that? I just want to sort of get your take on, on why you picked the focus on failure in the book. And I think you had a quote in the book about like cardiology, that you learn from your own successes, but you actually learn from others' failures. So yeah, I'd like you to chat to that a bit. It's
Yeah, absolutely. That's a great quote. In the book, we talk about and we reference some literature that kind of informs us why we would bother to look at failure over over success. And there was this famous study done in 2013, published in the journal Management Science by a team of researchers from Harvard University, University of North Carolina, Chapel Hill, and Emory. And what they did is they showed across 6,000 cardiac surgeons that when using a new technology, that individuals learn more from their own successes than their own failures. So this is individually. When I succeed, I learn more than when I fail, but they learn more from the failures of others than their successes. So there's a real psychological thing going on there where if we fail, we probably can't process it very well. We just refuse to recognize it. We want to bury it. We want to get rid of it. Whereas if we succeed, we're happy to reflect on it and think about what went well. On the flip side, when someone else succeeds, probably envy, jealousy, all these other things kick in. You're like, oh yeah, whatever, they got lucky, all this kind of jazz. But if they fail, we're happy to unpack it in excruciating detail and understand what went wrong. And that was kind of part of the reason why we went down this pathway, because we felt, look, we're sharing things from others. So we want to share things that people are going to learn the most from. And clearly from that study, it appears to be failures. And in particular, even for us, one of the things that was really important for us was to tackle this hype train that's head on, tackle this hype train head on that's kind of barreling down. It's going to cause a lot of damage for AI practitioners. And what this hype train's doing is it's setting expectations that are just fundamentally wrong. Executives, boards, everyone's just getting consultants in and thinking, oh, you just do AI just like you do anything. But it's not true. It's completely wrong. An analogy I like to give, especially for big companies, because when big companies do AI, they want to think of something that moves the needle. And they've been set the expectation that AI is revolutionary. It'll totally change your business. They go, okay, we want to improve our profit margins by 20%. And when we announce that on the share market, the share price is going to shoot up. And so to do that, they think, okay, we need to do this $100 million AI project or this $10 million AI project to have an impact. And what happens is that's like me today in my work gear deciding tomorrow I'm going to run a marathon. And I've never run before. And I'm well overweight. And I don't have good habits. A company doesn't have good processes. I don't have good behaviors. I don't have any of that good stuff. And tomorrow I'm going to decide to run a marathon. Well, what happens is you have a heart attack. Back when I lived in Gothenburg, Sweden, they used to do the half marathon, the Gothenburg half marathon there every year. It attracts runners from all around the world, but what it also attracts is a lot of locals. A lot of locals decide they're going to do it because it's kind of a thing you do. It's in your city. Each year, about 3 people have heart attacks. 3 young kids have heart attacks, of which about 1 dies every year. For someone who decides to do this half marathon, their body just can't handle it. It's the same for a big company that takes on a big AI project. They're going to take on something that's going to kill them, that's potentially has that danger. And so if you're going to train for a marathon, what do? You go run your 5K, you run your 10K, you do your half marathon, then you do your marathon. Along the journey, you buy the gear, you nourish yourself properly, you get into the right sleeping and eating habits and all that kind of stuff. If you want to do the big AI projects, you need to do the same thing. You've got to build it up. You've got to bring everything in place. And that's kind of what we're doing with the book. We're trying to tackle that hype head on and say, hey, don't believe what the headlines say. And then we're trying to say, to complete this AI marathon, you need to train up. And all these things causing other people to fail will help you train up and get to that point where you can run that marathon in a world-class time.
That I think one of the bigger challenges we've got, which is one of your early chapters, is that organizational maturity. Like they're starting from this point, and like the first thing we're going to do is the Gothenburg Marathon, right? And you kind of go, are you crazy? Like what's how do we create the literacy and the skills? Because not just about bringing in, say, a good bunch of data scientists, you need to sort of train the business and on how to collaborate. Because I often when we go to the medical datathons and things like that, which is you see this light bulb moment on where the clinicians, the subject matter experts, finally understand a bit what's feasible and achievable, and the light bulb turns on, where before that it's just these unrealistic expectations of magic, or hey, I haven't even phrased my problem in a way that's solvable. And once you give them that context of defining problems, because I often say the data scientist got the hammer, they just don't know what nut crack. And but to your point in the book, then you've also got the problems of data science, or bring out the sledgehammer, or the ththings like that. When let's start with the small
Exactly.
hammer and the small nut sort of thing, right? And build up
Exactly.
that capability. But I find literacy is one of the big shortfalls at the moment. That was something through the AI hub. So yeah, we're definitely finding a bit more now, really doing those workshops with business to really understand and what are the low-hanging fruit. And we'll chat about the sepsis stuff in a sec, because in medicine, everyone gets excited about all these clinical things, right? Like early warning scores. But if you think about the safety and the other issues behind it and the validation required, they're not the problems that hospitals should be adopting first, because there's just so poor maturity initially. What are some of the low-hanging fruit benefits that we can start with without deciding to tackle some of the hardest problems in medicine first, right?
Yeah, absolutely. It's such a good point. In my family, just kind of between us, we have a big joke that I'm the black sheep of the family, because if we look back at the history of my predecessors, there's a lot of doctors. There's a lot of doctors and surgeons. In fact, something that not many people know is my great grandfather was famously known as a blind surgeon. So he was a GP. He did it then. Back in the day, they did everything, surgery included. And in his late 70s, when he was blind, he would still be doing surgery, and his wife would be directing him what to do.
Oh,
So
wow.
he was he was one of those. And so my sister's a pediatrician, my brother-in-law's a radiologist, there's uncle's
Yeah, yeah, yeah,
pediatrician, granddad's you, all this kind of stuff. So all over it. And it's kind
yeah.
of funny. I talk to them about the AI stuff, and I go, okay, what do you think? And they laugh at me, and they go, only a naive technologist could make the claims that are being made at the moment. They clearly have no idea how a
Yeah.
hospital functions, nor how processes work. And I said, give me an example. They said, look at all this nonsense about how AI can detect a skin cancer better
Mm.
than a doctor, it's a specialist. It's rubbish. They said, Evan, do you really think all a specialist does when it comes to a skin cancer is looks at their screen and looks at a picture and says skin cancer or not skin cancer? They said
Yeah,
that is the biggest joke on the planet. Sure,
yeah.
AI might get that a little bit better, but that's not actually the way a specialist works. What a specialist does is they take your history. Do you have a history of melanomas in the family? Are you light skinned or are you dark skinned? Have you had any other skin cancers? Can I
Mm.
touch it? Can I feel it? Can I see
Mm.
what it's like? Can I put it under a
Mm.
special light? They do all these
Yep,
different things that an AI
yep.
algorithm with a single picture can't. And so
Mm.
you've got all these headlines that media outlets love picking up when someone publishes an article, and
Yeah,
they just run with it without
yeah.
even understanding, neither the technology people that built it nor the media outlets understanding that this is so far from reality. It's a joke. No, it's not going to revolutionize things. In our book, we famously, as you said, take Geoffrey Hinton's quote around all the radiologists will be extinct in 5 years.
Mm.
And that not happening. And I saw an article on LinkedIn yesterday that just made me cringe. I almost felt like putting a comment going, mate, you're clueless, because he wrote, oh, Geoffrey Hinton said everyone would be gone in 5 years. They weren't. Now look at that. But look at now what ChatGPT is doing. Out of the box, it can do X, Y, Z. And I went, mate, it wasn't a problem with technology back then. And
No,
and
no.
and it's not a problem with technology now. You clearly don't get it. You clearly don't understand what's going on. Another technologist on the sideline opining on something they're clueless about. And so I think some of the big challenges in medicine is it's a system. It's
Mm.
complex. It's
Yeah.
large. As mentioned, my brother-in-law is a radiologist, and what he talks about in a lot of the AI systems, and we've had companies like Maxwell Plus here in Brisbane that have built tools, and said,
Mm.
look, I love the idea, I love the concept. I'm not
Mm.
going to be down on it. But he said, let's talk about the value proposition. The value
Yeah.
proposition is better and faster recognition of issues. Like he works in trauma,
Yep.
in CT scans and MRI images and all this kind of stuff. And what he said is the problem is the current setup I have is I get the images out of a system, let's say it's the Siemens system, and I look at the image and it's all in that one system, process it, move on. And I can do each of them 15, 20 seconds.
Yep.
Now, using Maxwell Plus or another organization system, I need to get out of that system. I need to transfer the data across. I need to have it, analyze it, and then I need to come back to that system and do it. He said, it'll take me a minute and a half just to do that. And secondly, these systems are quite limited. He said, when I look at an image of trauma, someone's been in a car accident, they've damaged their kidney, I know that's the case. But what I also need to look at is all these things the AI won't detect. I need to understand, okay, the kidneys in relation to the liver, what's happening there? Okay, the stomach in relation to the liver, I need to understand the relationship between those different those organs inside the body. He said, AI won't do that for me. It does this narrow, and this is currently what AI is nowadays. It's narrow AI. It does this one task really well, and it's just we have a complex problem in a system. And so this system, what it also does, exactly to the point you raised at the start, is it creates problems with processes. It creates, which then lead to problems with data. So the data is not high quality because the processes aren't necessarily as good as they could be. But a hospital is a great place compared to a lot of businesses where processes are a lot better than many businesses. But it still leads to challenges around, you've got a complex system, you've got technologists who don't understand medicine, even in the slightest way, coming up with POCs. And Andrew Ning famously said, and we quote him in the book, that going from the proof of concept to the actual production-ready system, and we unpack this a lot in the book, is about 100 times harder. And we've seen this with Google's diabetic retina therapy systems that they tried to deploy in Thailand, that originally when they built the system, they curated all the images. And so all the images were of high quality photos that scans the retina. And so when they actually rolled it out in real life and people were doing it in Thailand, the problem that you had is the nurses are trying to do it quickly under poor lighting conditions, under someone who's not moving. They're not allowed to remove an image. It's no good. That's all they've got. And so a huge number of images and information that was getting uploaded to get processed was getting rejected. And it led to more issues and more problems than it did to solving things. And so we want to raise awareness for that in the book. We want people to be aware that these things are hard. They're valuable. I'm an optimist. I think it can have a huge impact, but we need to be cognizant of the challenges ahead of us.
Yeah. Because in your book, you talked about sepsis, and as you mentioned, Atawi, we've now built out all the data with Queensland Health for all its 14 ICU units, and that sort of TRUES score and those other models. There is real business value if those models would work. Because an ICU bed day is $5,000. So if you can intervene early on sepsis and prevent the blood infection, most people don't know what sepsis is, right? But it's the largest cause of death in ICU. It's about 30% of fatalities in ICU. But if you can intervene earlier to inhibit the infection, there's lots of dollar savings to the health system and things like that. So it tends to be the gold standard problem people talk about for electronic medical records. But again, it was really interesting you brought that up as a case with the EPIC sepsis model and its deployment and some of the shortcomings. But the other side of it as well, to the point you made, you might have this really well-performing algorithm, but the system you embed that into has a lot of influence. Like, what's your medical response team? Is it going to introduce automation bias? It's almost like you need to revalidate in the clinical setting, is this actually leading to better outcomes? Because the model, the way the clinical staff interact with the model will change the care pathway, right? It's
massively. And in the US, we cite a statistic there, to your point, that every year about 1.7 million US adults develop sepsis, and it kills about 270,000 annually. It's a horrific, it's a horrific killer. And exactly to your point, some of the challenge with the EPIC sepsis model, and this is what I find fascinating too, where the media overhypes the AI, but at the first opportunity, they'll drag the pioneers through the mud. And that's effectively what happened with the EPIC sepsis model. And what we do in the book with that is we try and show it for everything it is. So we pick up all the stories that attacked EPIC on the sepsis model and said it was no good and they rushed it to production and all this kind of stuff. And what we really show is, no, it's complex, exactly to your point. In some hospitals, they send off a test to a lab. In some hospitals, they don't. And in those hospitals they do, you want to use that test result. You want to. And where they don't, you clearly don't. And so you almost need multiple models that have multiple different features in them that are going to create a probability score for whether this person needs to receive strong doses of antibiotics or something and be able to be treated properly for this horrific condition. And so what also happened with EPIC, what I respect a lot, is they didn't give up on it. They kept iterating it. So what society and everyone needed to have, it's the same with autonomous vehicles that we've got nowadays, right? because they don't work with full autonomy from day one, people are like, oh, this whole autonomous vehicle thing's a joke, everyone's promising it tomorrow. And it's like, no, it's a long-term project that the benefit that we can clearly see of vehicles being autonomous is enormous. The number of road fatalities would go down. And for people who are scared of flying, I always tell them, hey, look, I tell you what, did you survive the trip to the airport? And they say, yep. And I say, well, that's the most dangerous part of your flight done. As long as you make it to the airport, statistically, that is the most dangerous part of the entire trip. Now you're fine. Now you can relax in the plane. And so it's similar with these things where there's a lot of challenges around ensuring that we don't lose support for these systems as they're being built. And what I respect about Epic is they've stuck with it. They've been with it over 10 years building this model. It's a slow grind. It's a thing that just improves little bit by little bit every iteration. And again, another example is ChatGPT. One of the things that frustrated me more than anything else when ChatGPT came out in the first year as they were releasing new models, everyone going, this is just going to get exponentially better. It's getting exponentially faster. First of all, they don't even know what the word exponential means. But secondly, they're completely wrong because they're one of these overnight AI experts on LinkedIn, one of these AI voices. And what's happening is they haven't been following the research. Before ChatGPT, there was GPT-3. Before that, there was GPT-2. Before that, there was GPT-1. Before that, there was a plethora of different natural language processing models using things like Markov chains and whatever else that you've got on your mobile phone that do these things. And people didn't recognize that. This is 10 years of work, people. It didn't just suddenly happen overnight. And we've got to stick with these things. And the problem with the medical arena is, unfortunately, it is life or death. And unfortunately, at a miscalculation, someone could die. But what we've also got to look at, and I talk to my sister a lot about this, is like with all AI systems, humans get it wrong too. And we've got a vision to get somewhere. And along the journey, it's not going to be easy. And we've got to stick to the path knowing that the potential future impact could be huge.
Yeah, it's good that last point as well, that it's almost like this expectation around perfection of what the system's going to do. And and I think, what we really need to do is carefully baseline the current human performance, which we rarely do, and then understand, are we working with a system that's better? We had another project similarly on the medical data which I think was one of those lower hanging fruit things, was can we predict how many more days that patient's going to be in the ICU bed sort of thing. So again, something that's not as much risk, but it's helping with workload management and, whether we're going to be occupied. So do we start routing some patients to other wards, other hospitals and stuff like that to, manage capacity.
I'll give you really, sorry, keep going, Kevin.
Yeah. When we first built the model, all of us were disappointed with the performance. Oh my God, we're only 70% accurate. But then when we went back and validated the human data that was put in to drive the prediction and the workload forecasting, we're way better than the human. So you sort of almost wanted to say, hey, this algorithm's going to be an uplift and perhaps reduce the workload of a clinician having to sit down each day and put another estimate in, to give a bit better performance. But it's funny, that whole argument about, we're setting the bar really much higher on a lot of things when perhaps this other system's going to lead to good business outcomes without, making an impossible goal, right?
Let me give you, sorry to interrupt you before, but let me give you the point that's exactly related to that just nails it so beautifully. And it was in the lecture I teach at University of Queensland. I teach the 4th year business analytics strategy. And in the very first lecture that I give of that course, I try and make the students think really hard about data-driven decision-making. And at the very first half of the lecture, I kind of go through everything that goes wrong when you use data and everything that's a problem and all the challenges you face before halfway through turning it around, going, well, what options do we have? And showing that, well, data-driven decision-making is really powerful. But I kind of want to instill in them a bit of humility around that data-driven decision-making. But one of the slides I show is one of the challenges that addresses exactly what you said. And it was a paper published in the Journal of Experimental Psychology in 2015. And it was called Algorithm Aversion. People erroneously avoid algorithms after seeing them err. And what the paper did is it showed that if an algorithm makes a mistake, people very quickly lose trust in it and then just stop using it and just want to throw it out. They throw the baby out with the bathwater. They would just want to get rid of it. They just don't trust anymore. I'm not going to use it, in spite of the fact that they themselves make tons of mistakes and things go wrong all the time, yet they'll stick with it. And it took until 2021 from a paper from the University of Michigan to really understand why that's the case. And it was fascinating when they came up with the reason. It was almost like you had to laugh, because they said the truth is that we could find is that humans can justify their mistakes. Machines don't. So machines don't output a list of reasons why, oh, I stuffed up because you gave me the wrong data, because you entered the wrong parameters, because I'm not trained on this data, because of model drift, data drift, everything. And humans, on the other hand, will make a bad decision. Go, oh, I was out on the town last night with the boys, and we just had too much to drink, and I'm shady today, or just broke up with my girlfriend, or this isn't in my area of expertise, and we forgive the human being, and so we don't fire them. Whereas we immediately fire the algorithm because it simply can't do it. And so after we read this paper, I had a project with one of Australia's large retailers where we were doing forecasting of future sales. And again, to this point, we could do 99% better than the people. So we were better on everything, but there was a couple that we weren't better on, and they just blocked the algorithm. They're like, no, we're not deploying it until it's better on this. And you sit there going, what is going on? Like, we're better 99% of the time. And because of these two cases, you're not going to do it. And so anyway, they blocked it. And we realized technically we weren't going to win this one, because if we improved it for those products that it wasn't forecasting well, we'd have to lose it on other products. Other products' performance would decrease. And so what we realized the solution was, it was to think outside the box and to justify the mistakes. And so what we'd do is we'd have a further column that would say, provide a comment around the forecast in terms of, hey, I'm not so confident here. The data's pretty thin. It's intermittent. It's not solid. It's kind of, and it put all these things. And when they saw the comments, if it was off, then it was okay, because we were providing them, we were doing what humans did in giving justification. It was fascinating to see that then work. We had nothing to do with the technology. It was all psychological.
Yeah. Because a bunch of like meetings around governance and things like that, inevitably it comes up about explainability. Oh, our algorithm must be explainable. And, and you think back to human behavior. Oh, okay, well, to the example you gave, the humans will explain why they made a wrong decision or something like that. And perhaps even invent something completely irrelevant to why they made the wrong decision anyhow. Where, those are things that, we can build into algorithms. But there's another paper out that they did an experiment, and humans trusted an algorithm that was wrong yet explainable more than an algorithm that was more right but less explainable. And you go, oh, holy crap. It's like...
Exactly. And that's one of the big things in the book too that we talk about. Like, I know you and me, with our technical backgrounds, when we love I love the technical stuff, at least for me, and I know you even do coding, Kelvin. I've seen some of the code you've written. And I one of the things that obviously we really enjoy is that intellectual curiosity, that ability to dive into something technical and understand it more. And what the book showed me and Doug, and it was kind of funny when we were writing it, because we were both thinking, oh, this will be great. It'll show all the technical failures and how things go wrong, and we can justify delving into more sophisticated models and doing more analysis. And it showed just the opposite. It showed exactly what you've said. It showed the real failures in production, in day-to-day usage of AI systems, is all human. It's all due to humans. And if we come back to the thing you mentioned at the start of our conversation, where you talked about education and university degrees, the problem you've got as a data scientist going through a degree, even a master of data science, and we analyze this in detail in the book, in the people chapter, is that everything you learn is just data science and maths. Now, don't get me wrong, you must learn that to be a data scientist. If you don't learn the data science and the maths, you can't be a data scientist. But the problem we've got now, when we look at the success of these projects, is the technical reasons for failure aren't even in the top 10 of the reasons that we had. It's all kind of the people side of stuff. It's all those things that you just mentioned around a more explainable but less accurate is more important than a more accurate and less explainable model. And we really need to think harder. And I know there's a lot of research on this, on HCI, so human-computer interactions. And there's in Stanford, they've got the, I think the HCAI unit that kind of looks into these things and tries to unpack them. And I think that's, for me, that's the next frontier of a lot of the work we're doing, because as great as ChatGPT and all these other things are, And as great as people building millions of specializations and applications on top of it, we will still see 80% of them fail because of the human side of things. And so you're to the point that we need to dig into that adoption, production, getting to production, that going from POC to production, all these kind of things. We need to dig into it and spend more time solving that, because that's the elephant in the room.
Yeah. So I think this comes, you've got that chapter on strategy, and that are they solving the right business problem with which I think sort of comes to that element, and later you talk in technology about, are they using the right size model to sort of, starting small first and things like that, which I think are really, really good. But I often find, that agreement up front about, well, what's the problem we're trying to solve? What's the objective? What's the benchmark or the baseline? But a lot of times you quickly fall into a trap. We're doing this project with with drones to measure marine debris. So again, it's a computer vision problem to identify, on the beaches in the Torres Strait, plastic waste. And if you think about the goal, it's to guide cleanups. What beaches need to be cleaned up? If we give a contract out, sort of in sort of the biodiversity market, they want auditable sort of traceable things if they're funding biodiversity or carbon trading, things like that. So can we go out and baseline the cleanup's been done, and we can verify that that's been done to a certain level, and then work out, well, what's the reloading of that waste that's coming in. But very quickly, you dive down into a data science project, and you're pinpointing using computer vision the location of plastic waste, and people are starting to say, oh, we've got to factor in distortion in the camera lens and stuff like that, and going. So if you nail the objective function is about, can we precisely place each bit of plastic? That's sort of what the technologists dive down to, the objective function, as opposed to, can we just work out a density function for that 50 square meters as a rough approximation? Because that's all we need to solve the business problem. So, it's about sort of right sizing the business problem a bit there, right? So
I've got a great story for that one. So when I finished my PhD, and probably you'd understand this very well, is I was probably at the pinnacle technically of my whole life. So that was technically the top, because you're right in the depth of proving mathematical theorems, of pulling together algorithms, all this kind of stuff. And when I went into my first job in Sweden at the Fraunhofer Chalmers Center, I say openly to people, I effectively had to be micromanaged, because what I'd do is I'd seek this technical perfection in each algorithm, and the guys would have to come in and just stop me and just be like, Evan, stop. We are a commercial business. I don't pull myself up all the time, that you've got this precision and recall of these incredible values. It does not matter to us, or this is within 0.0001% of the optimal solution. We've got a fixed budget. And in fact, to your point that you said before, we've just got to outperform the humans. Once we're done outperforming the humans, that's enough. And make sure it's not obvious. Like, we want to make sure there aren't any obvious things that they could do better. So make sure you cover all that as well, with a few heuristics. But it was kind of embarrassing for me that first 6 months to dial this technical drive in me way back and go, stop focusing on the technical problem first. Focus on the business problem first. And gain your context from that. Gain your context from, what is the outcome, exactly to your point, are we trying to achieve here? And what would make that possible? And in particular, in business nowadays, how do I get there as fast as possible? I need to be there yesterday to show value to the stakeholders, to continue this project. Because if they're not going to wait, again, like a research project, for me to spend 10 years proving Fermat's last theorem like Andrew Wiles did, locked up in a basement, and suddenly announcing one day, here's the proof. No one's got that patience in the real commercial world.
No, you get one chance as a PhD student to have a crack at it, right? You've got 3 years to explore it. So what are some of the things that you've found, like going into an organization, sort of assessing their maturity? What are those steps you try to take to sort of guide them on that sort of journey?
Yeah, really good question. When we look at the lessons we've got in the book in terms of what causes things to fail, on the whole, and I'll give the answer to the question, I'll give you a bit of background. We've got this massive long tail of reasons that cause projects to fail, like probably over 100 or something I think we had. And that's not helpful. Like just listing 100 reasons doesn't help anyone. They say, well, how do I deal with that at every project? Am I supposed to have a checklist of 100 reasons? That's not going to work. So what we did is we cut it off and we focused, like I think, on the major 20 or so that do 80%, that cause 80% of the pain. And within that there, what you notice is in terms of that maturity of an organization and getting them on the right path, is there isn't one thing that suddenly will take you from what we analyze in the book for analytically immature organization is about a 90% failure rate to what you get if you're analytically mature, which is about a 40% failure rate we calculate. And so there's not one thing that does that. If you take all those 20 reasons and you fix them, so number one, you get the strategy, you get the AI project aligned with the business strategy. Number two, you get the right people. Number three, you make sure you got the right data and it's high enough quality and it's not all siloed in locations around the place that are inaccessible. You make sure the leadership's aligned with what you're doing. You make sure there's a bit of a culture of analytics. You make sure you got the right tools. You make sure of all these things. Then each time you make sure of that, you perhaps reduce your failure rate from 90% down to 86%, then from 86% down to 83%, then from 83% down to 79. And each little slice you take reduces that failure rate. There are some bigger ones where if you don't align with the strategy, I think it's bigger, but nonetheless, there are people that can pull off a project and then convince management, hey, this is a great thing, and they keep it. But it's not always the case. And I think that's the biggest piece, just kind of coming in and this is the most undata scientist thing you could possibly probably say, but you get an intuitive feel for how an organization is across all these factors that cause failure, because it isn't just black or white, yes or no, the strategy is aligned. Sometimes it can or can't be, sometimes it's a bit gray. It even comes down to what's our definition, if we just take a step back again to illustrate this point, what's our definition of success? Like, what does success even mean? What does failure even mean for an AI project? For example, sure, we can clearly say a failure here where we lost all the money, there was no outputs, there were no results, it was negative for the organization. That's a failure. And a clear success is we delivered on budget, on time, we delivered all the desired objectives, and we had the performance impact on the business. But between those two, there's a massive gap. There's, oh yeah, we delivered it, it's a little bit late and a bit over budget, but the actual outcome was better than we ever suspected. Is that a success or a failure? We didn't quite deliver the scope, but we got it in budget on time, and the benefits just a bit better than what we paid. Is that a success? Like, it's so hard to say. And so similarly with organizations, it's almost like you can do your data maturity assessment. They're great. That'll give you some data to form a baseline. You can talk with the teams around, give me an example of other AI tools you've used. What other analytics projects have you done over time that have been successful or failures? You can kind of gather this data, and at some point it's almost like you need to draw an intuitive conclusion, an undata scientific one. At some point there's always going to be an art where you're saying, I think this is going to swallow you up. I think you guys are in trouble if you give this a shot.
I kind of like that iterative approach to delivery as well, right? Because again, you've got there about starting small and simple, because are we building the right objective? But typically, as a data scientist, a model builder coming in, I've read this paper about the latest LSTM model and I'm going to whack that in place, and hey, nothing seems to be working. So you're not going through, well, what's the simplest model I can start with, fewer sort of features and things like that, sort of use that as a benchmark and then try to iterate from there. But even getting to that process of going, okay, well, let's take that model and think about how it's going to be used subsequently down the pipe, right? Because you get so infatuated in just this one small piece, you haven't actually thought about its, how that result is sort of adopted and used later on. So I very, very much like that iterative approach. But nearly, again, that sepsis project, I've probably got 4 FTE years of, failures in your book just on that one project.
It's so true.
And part of that was just getting too crazy with the model and stuff like that. The new data scientist come in and he's infatuated with this, and then he wants to use Kubernetes and all this sort of stuff. Like over engineering the solution. So
the one, there's a great one in the time series forecasting we do in now. Sorry to interrupt you there, but it's worth mentioning. Whenever I've done time series forecasting projects in large organizations, like you could be forecasting sales, you could be forecasting maintenance outages, you could be forecasting failures, you could be forecasting all sorts of things. the very, very first step, and data scientists hate it. They absolutely hate this, is your first model, your baseline that you're going to do is the absolute no effort naive model. And what the naive model is, what was it last week? Or what was it last month? That's your forecast. Or what was it last year, depending on what kind of cyclical behavior, or yesterday. That is your baseline to beat. And the embarrassing part is, in general, in I would say 60% of the cases, it is incredibly difficult to beat the naive. It is incredibly difficult.
Yep. No, exact same experience. Let's step down a couple of other chapters you've got there. People. Again, you've come from that traditional data science background. I feel that's becoming less and less now with projects because, you've got LLMs and computer vision, and there's probably a lot more focus now on the engineering. But what are you seeing as the changing skill sets now that organizations are requiring to deliver these projects?
Really good question. There's one thing we discuss a lot in an earlier chapter, and we do as well a bit in the people chapter. It's this kind of analytics translator that we talk about. It's not a new concept. It's been around for a while, but we kind of want to bang the drum on it and raise the awareness. And in the clinical sphere, we're seeing now in Australia these roles of titles like clinical analyst. And it doesn't mean like business analyst perspective. It means analytics. And I've seen people coming out now. They're wanting people with a medical background, but have also got data scientists. They want the two together. And we're seeing roles like that and this really bridging roles. And that's what we call an analytics translator in our book. It's this person that bridges the technical and the domain. So they connect the two, because there's a real disconnect often between a data scientist who's done that purely theoretical work during their degree, and let alone they've done nothing to do with project management, stakeholder management, communication. They've done none of that stuff they should be doing. Also, that they've probably done none of is having any domain experience in the area they're going to work in, because a data scientist can go to many places. They can go to retail, they can go to healthcare, they can go to agribusiness, they can go to supply chain, they can go to technology, all these different areas they can go to, and each one of them is fundamentally different. And so what we're seeing is that the critical need for these people that span both aspects of the domain and the technology, and that's kind of becoming really core to the success of a lot of projects. The ML stack is growing and growing and growing over time. We've got everything from, and people ask me, oh, can we do an AI algorithm? I say, where's a team? And they say, what do you mean a team? I said, well, you're going to need the data scientist. The data scientist probably isn't going to be your data engineer, so you're going to need a data engineer too. You're going to need the software engineer who's going to build the application, and that software engineer might split into 3 roles, potentially with front end, back end. You might need a full stack. You're then going to need your cloud engineer to deploy it to the cloud. And they look at me and their eyes are going wider and wider. And they go, what about the product owner? What about the project manager? What about the business analyst to get the requirements? What about when you're in production, the ML ops manager? What about the, they look at me and just like, wait a second, I just want an AI model. And I'm like, yes, you do. And that's what you're going to need.
No, I find the same thing. And I guess this is the challenge when, people are just out there, more like system integration people and, development people. They know how to deploy a model, but there's all these other elements around the project that are missing. And we've sort of mapped out a bit. Again, we even see that element around the validation side as being quite specific, how to sample data and, what data to focus on and things like that is quite a specialized role. But then that mapping back to the business, we've really identified that, almost AI solution architect, right? That, can sort of translate between the data scientist and the business and real, but also understand that whole system you got to embed it in and what governance and regulation requirements you got. And, have I got the data privacy stuff sorted? And, but, in your book, you do spend a bit of time the data stack is so significant, right? It's in all of this. And I guess, many projects start out, they have this idea, but they don't realize they don't actually have the data, or their maturity around data management in their organization's really bad. And, it's really hard to make progress in those projects, right? It's
massively challenging, but also therein lies the opportunity. The harder it becomes, I think the more of a competitive advantage that could be for the organization if they're willing to double down on it. And they've got to see it as a long-term project. They can't think there's a Band-Aid I can put on this and it'll be fixed. They've got to realize, okay, these data issues arise from process issues further upstream. Like,
Yeah.
data issues don't arise magically. Sure, you could screw up the configuration of your database and some ETL workflows and other things like that. That's possible. But
Yeah.
more often than not, it's because your processes are messed up. It's because the frontline team don't bother to enter the birth date properly. They just pick the default value because they're under pressure. Or they
Yeah.
don't bother to record the last name because they're under pressure. They got to move quickly. It's just the first name, boom, boom, boom. They're not given enough time to push
Yeah.
things through. The people setting up the systems don't think about the time that's required to do something properly. And so, or doing that's just so boring that they just couldn't be bothered. They're just going to do it as quickly as they can. And
Yeah.
so what I think happens there is the discovery of the data issues leads to an incredible opportunity for the organizations to overall improve themselves. It'll just so happen that that overall improvement will flow through to high quality data, which will flow through to excellent AI models, which will flow through to great competitive advantage against your competitors. And I think there's a massive, massive opportunity there, but it requires some willpower. It requires time, dedication, budget, all these things. And if you're on a quarterly reporting cycle, that can be hard, unless you're an organization like Amazon that's explicitly stated, we don't care. We're here for the long term. I'm ignoring these short-term fluctuations. Then it's really, really hard, especially even if it's not your business and you're a CEO that's come into a stock exchange listed company and it's been struggling, or they really bring you in. Often, if the other CEO hadn't retired and you've been brought in to take over, then there's a problem there, right? And they want you to do better. Then you're under a lot of pressure to move quickly. And so to sit down and say, hey, the next 2 years, we're doing this big process mapping, data engineering, data quality improvement project is not going to get anyone super excited.
Yeah. So on that sepsis project, one of our goals was to take, say, a couple of the algorithms published in the US, like Trues and whatnot, and say, well, how does it apply to our Queensland data? Let's validate it. But the biggest challenges we had were around data, and I think back to your point about process was really a big dictator of the data structure, and like you said, some of the algorithms fail because different hospitals might not do certain blood tests or things like that. So you've got that variability of data. We had a lot of problems even just validating the algorithm, because the validation of the algorithm was done on ICD-9 codes, which are billing codes used in the US, but we don't use those codes in Australia. So actually having what is the definition of sepsis? That's a really tricky question to answer, and then deriving that from the data values, and sort of comparing apples to oranges sort of thing was a challenge. But then how patients present it and how do they show up in the data set and things like that. So we just found the data element was quite critical. And you've also got that problem, which I think is a big challenge for machine learning. Everyone thinks I can just take maybe this off-the-shelf model, and apply it to my data and it's going to work. But, the thing is, we've always got that domain shift element. And I think that one of the big problems with Epic was that moving from one hospital to another, the data's quite different. It's got a different shape. You go to a burns unit, the way they get infections is quite different to a general hospital and stuff like that. It's and I think that's a problem underestimated a lot, is that how to deal with domain shift and refitting and fine tuning. Whether you can build a more generalized model, that's really questionable at the moment, or whether you really just want to fine tune to your particular organization, things like that. But you also talked about the book about the challenge that people had of, I've just done a POC, but to actually make it mature enough to run in production, that's a big gap, right? It's a
huge gap.
Chat to that a bit.
Absolutely. And there's two things also to mention on what you were talking about before. We talked about this years ago. I remember I sat down with you and we're talking about the data standards that exist in the US. And I think one of them was SNOMED or something like that. And there was another one. There are a couple of them that we're looking at. How do we bring it over? And if you'd bet on that at the time, saying, look, we don't have one, let's go for it. Let's commercially tie ourselves to this, you would have been in big trouble. Because when I talk to the organizations in Australia, and especially coming from the federal government, they're going with the FHIR standards, the Fast Health Interoperability Resources. standard. I was at a conference in Canberra where they just were like, this is it. And imagine as a commercial entity, you've tried to do that. You've tried to bring this thing over, and now all of a sudden the rest of industry said, no, we're going the other way. Like, it can be incredibly challenging. I mean, hopefully it wouldn't happen because you'd be at the conferences where everyone's talking about what standards and that. But if you want to be a first mover and get an advantage, you could be in big trouble. And so that in itself, getting that data in the first instance isn't hard. But to the second point around going from POC to production, Andrew Ning famously said years ago, he said, those of us in machine learning are really good at doing well on a test set, but unfortunately deploying a system takes more than doing well on a test set. And he kept expanding on this, kind of saying, look, we collect data from Stanford Hospital where we train and test data from the same hospital, and we can publish great papers showing that we're comparable to human radiologists in spotting certain conditions. He said, it turns out if you take that same model, that same AI system to an older hospital just down the road with an older machine, and the technician uses a slightly different imaging protocol, that data drift causes the performance of the system to degrade significantly and it becomes useless. He said, whereas a human radiologist can walk down the street to that older hospital and do just fine. So it's kind of, he said, there's this enormous gap between proof of concept to production. And I think it's so massively underestimated. People think it's a factor of 10. It's not, it's a factor of 100. And we emphasize that in the book. It's a factor of 100. Proof of concept. So if your proof of concept costs 50 grand, you're looking at 5 million to get a fully production ready system in many cases. Sometimes you can get lucky and it can be a factor of 10 and you can get out the door with under $500,000, let's say. But often you should be aiming for that 5 mil. And that's if you think properly and you get outside your data science box, because you've got change management coming down the road, especially with an AI system. People are going to have to change behaviors more than just normal IT systems. You've got difficult mathematics and edge cases that'll pop up. So in the POC, you typically avoid all the tricky cases. You'll do the easy stuff just to show that it works. But unfortunately, the easy stuff, as with the typical 80-20 rule, is only 20% of the effort. The 20% of edge cases is 80% of the effort. And in fact, there's probably, I bet you, going to be a handful of edge cases that you'll never, ever be able to solve. And those ones are going to have to be routed through a separate mechanism that's going to require human intervention to be able to get correct. And so I think people massively underestimate that POC to production. And we talk about, I think, in 3 or 4 instances in the book where both me and Doug just really need to point out that even in a previous business I used to work with, we used to build for organizations these models that they would use. And then the expectation internally from the management was that, okay, we've now got a model that you've built for this company. Now let's go sell it to the world. And it was like, dude, that was a POC. We only got 80 grand to build that thing. That's effectively, there's nothing to sell to the world here. There isn't a refined model. In fact, that company that came to us got us to build that model, they stuffed up because they didn't do their proper due diligence and should have seen actually there's an off-the-shelf tool over here that they could have used, or they could have used that tool if they just improved a few processes, which would have been cheaper and more beneficial than us building this model. And yet the management would always be thinking, oh, we can take this now and sell it to the world because we've got something. We don't. There needs to be another $1 million of investment before that thing can even come close to being sold to anyone. Because the moment I'm going out and telling you, Kelvin, hey, Kelvin, I've got this great tool, buy it. You didn't ask for it. You didn't want this tool. It's not something you needed. And so you're going to look at it with quite critical eyes and go, wait a second, it's missing this kind of standard dashboard feature that I expect of a tool like that. Where's that? And you're like, oh, well, we only spent 80 grand building this simple UI. It's like, well, where are all the user securities, the account profiles, user management? Where's, we don't have that yet. It's just a model. It's kind of like, there's such a big gap.
Yeah. And even that element like data drift, you want that monitoring system to have, some element of human feedback, designed into it, that there's those calibrations and checks that are ongoing, right? Because, quickly things can run off the rails, right? And we're just chatting the other day with someone about, we're definitely seeing benefits of language models and things like that, but it's peripheral. And then you're looking at agentic AI emerging and you go, well, its ability to run off the rails and sort of, infect actions elsewhere it's going to be really quite interesting to build those sort of guardrails and sort of human feedback and things like that into it to, stop it just, just going a bit crazy of, and all of a sudden flooding a whole bunch of other data areas. It's going to take you, months, if not years, to clean away all of the stuff it can
Yeah,
create
exactly.
within, a couple of hours. It's
But we've
yeah.
kind of seen that with content online. Like you've seen from an SEO perspective that
Mm.
these tools are being used to generate just SEO traps of websites that just produce
Mm.
like over 1 million articles and now just become the
Yep.
center of the internet because they can do it at scale. It's already kicked off. And what I think is unfortunate about a lot of this stuff is often when it comes to a regulatory perspective, it seems to require a disaster, a train wreck before anything happens. And then unfortunately, when a
Mm.
train wreck or a disaster happens, the reaction isn't one of let's be reasonable and sensible. It's one of let's lock this thing down, let's control this thing, let's put draconian measures on to make sure that never happens ever again. You're like, oh no, this is exactly where we
Yeah,
didn't
yeah,
want to
yeah,
be.
yeah. Yeah, we've actually, working with some hospitals at the moment that have put a pause on all AI projects because of, the talk of regulation at the end of last year. And you're going, so what, even R&D where it doesn't touch a patient and all this sort of stuff, it's just that overreaction. Oh, the government is saying we've got to have an eye on this, but there's no measured balance around what that risk and exposure and policy is, right? There's just this blanket reaction to, oh, stop. And you go, well, hang on, if we don't still allow it in like R&D in a sandbox, how are you going to build your organizational literacy and maturity, right? It's um yeah, I think the regulation, can be, I'm pro guardrails. I think good regulation will help people move forward, but I can easily see people, over regulating and really just putting the brakes on certain things.
It can, and it gives industry certainty. So we have a large organization that we're looking to onboard with the current company I work with, Ubity. And we're going through the legal process and procurement and everything. And at some point, we're kind of showing them these AI tools that we've built off the back of a large language model that assist with the entire process that we're helping them with. And they effectively said, "Oh no, can we switch that off?" And I was like, "Well, why? That's our value proposition." And no, can we switch it off? And the reason why they wanted to switch it off is just uncertainty. They're like, "Well, we've got these laws in the EU, and we kind of work in the EU, and we're just not sure if that applies or not. And we're
Yeah.
uncertain what it means for us as a user of this." And then we can see that in Australia, this is going to start happening soon. It looks like Singapore's got something, and they just said, "Look, because we're global, this is just going to be too hard. So it's
Mm.
better we just switch it off and just don't use it." And that's a
Mm.
real concern, right? With all these hodgepodge rules and regulations around the world. And this is something that I appeal for in Australia. Like, let's please not come up with our own unique AI regulatory framework. Can we
Mm.
please piggyback on another country, another union, another
Yeah, yeah,
whatever,
yeah, yeah.
so
Yeah.
that anyone that builds a system over there is guaranteed it'll work with us too. And
Yeah,
anyone who
yeah,
builds
yep.
a system here can take it straight to there and we'll get the benefits in both places instead of us
Yeah,
deciding,
yeah.
no, we're unique. We need our own set of rules. It's just like, please don't do that. You're going to just make it impossible. And that leads to situations like these organizations that effectively say it's just too hard. We don't
Yeah,
care.
yeah.
It's too hard.
Yeah.
No AI.
And there's definitely, a business lobby group will see regulation as putting up a barrier to entry into certain markets, right? It's, for their own sort of economic purposes, not because it's the right thing to do. And that's happened,
Yep.
many other places as well. Yeah, well, look, Evan, I think, it'd be good to have a bit longer chat, but we've sort of, used up a fair chunk of time already. Yeah, I've really enjoyed it, and I could, keep chatting about these sort of things. So, yeah, thanks, Evan. That's probably it for today, and I'd love to have you back again in the future.
Absolute
Um,
pleasure. Really enjoyed it. Thank you for having me on, Kelvin.
yeah, thanks. Okay, so if you found this discussion valuable, be sure to like, subscribe, and share this episode with your network. KJR is committed to helping organisations navigate AI adoption with confidence. So if you're looking for expert guidance, you can contact us on our website, kjr.com.au, and you can find a link in the description. Thanks for listening, and we'll see you next time for more conversations on trusted AI innovation. Thanks, Evan.
Hey everyone, thanks for tuning in to another KJR VDML podcast. We have a bunch of events, AI workshops and training coming up. For more info on these, kjr.com.au/training. As always, don't forget to like and subscribe and we'll catch you on the next step.